Bismillahirrahmanirrahim. Okay, so let's get started. And this is a new topic in this course on optics. This is called the Fermat's principle or the principle of least time. Remember, this principle was presented by mathematician Perry Fermat in the year 1850 or 1858. 1858, I think. Okay, what is the statement of this principle? Remember, this Fermat's principle or the principle of least time talks about the propagation of light from some source to some observer. And according to the statement, a light ray traveling from one fixed point to another fixed point follows a path such that compared with nearby paths, the time taken or required is a minimum. अच्छा मतलब क्या है इसका? Suppose this is some source of light over here from which light is spreading or emanating in all direction, and this is some observer over here. Okay, so you can say these are 2 points. So let me call this point where the source is present as point A, and this point B where the observer is present. Okay, so according to Fermat's, if light is moving from this source A to observer B, so it will take the shortest possible path. Shortest possible path का मतलब ये है कि लाइट यहाँ से यहाँ तक उस पाथ को फॉलो करेगी जिस पर इसको सबसे कम टाइम लगे, जिसको आप शॉर्टेस्ट टाइम कहते हैं. ओके, इसलिए इसका नाम, इस प्रिंसिपल का नाम प्रिंसिपल ऑफ लीस्ट टाइम भी है कि लाइट उस पाथ को फॉलो करेगी जिस पर इसको सबसे कम टाइम लगे. अच्छा, अब फर्मास प्रिंसिपल को हम टेस्ट करने जा रहे हैं और ये फिर एप्लीकेशंस बनेंगी इस प्रिंसिपल की कि क्या ये जो फर्मास का प्रिंसिपल है या उसकी जो स्टेटमेंट है, क्या इसके बुनियाद पर हम कुछ इस्टेब्लिश्ड कॉन्सेप्ट्स या ऑब्जर्वेशंस को प्रूव कर सकते हैं कि नहीं. तो हम लॉज ऑफ रिफ्लेक्शन की तरफ आते हैं. सो वी आर गोइंग टू प्रूव द लॉज ऑफ रिफ्लेक्शन यूजिंग फर्मास प्रिंसिपल. तो अगर हम फर्मास के प्रिंसिपल को यूज़ करके लॉ ऑफ रिफ्लेक्शन पर पहुंचेंगे तो इसका मतलब क्या है कि फिर फर्मास प्रिंसिपल ये सही होगा. एंड रिमेंबर, लॉज ऑफ रिफ्लेक्शन टॉक अबाउट the reflection of light. So again we draw over here some reflecting surface. Suppose this is some mirror, label is mm prime, and here is some light source at point A, and this is some other point which is labeled is B over here. तो ये सोर्स है, यहाँ पर कोई ऑब्जर्वर है, और अब हम इंटरेस्टेड हैं, जाहिर बात है यहाँ से यहाँ तक लाइट different paths के along पहुंच सकती है. So remember, the shortest possible path between point A and B will be this path. But remember, we are talking about reflection now. Okay, so इसका मतलब क्या है कि लाइट यहाँ से अब किसी और पाथ को फॉलो करेगी. So now there are many paths which light can take in going from point A, hitting this surface, reflecting surface mirror B mm prime, and then reaching point B. So different path हो सकती हैं. So for example, let me draw this figure again over here. This is your mirror. This is the initial point, the source from which light is coming, and this is the final point where light will reach after reflection. So light can follow this path, coming straight downward, hitting the surface over here and going this way. It can move from here to here and can go to the final point. So there are infinite number of paths. तो अब सवाल ये है कि लाइट यहाँ से किस पॉइंट पर हिट करेगी, इस मिरर पर, और फिर पलट के आएगी इस पॉइंट बी पर। तो इसका मतलब क्या है कि ये जो पॉइंट ऑफ इंसिडेंस होगा इस मिरर पर, वो डिसाइड करेगा उस पाथ को कि कौन सा पाथ इन सब में सबसे लीस्ट टाइम का होगा। Okay, so just consider a general sketch where light is coming along this path. So it is coming from point A, hitting this mirror at point C, and follows this path and reaching from A to B. Okay, and we say this point A, this point C, which now determines uh, the shape and the amount of time in reaching from A to B. Okay, this point C is some distance x away from this point A horizontally. Okay, so the horizontal distance between point A and C, this is labeled as x. The horizontal distance between the source A and B is labeled as the total distance AB. Okay, so AB, this is the total length L. X, remember x is the distance of the point where the incident ray will strike the mirror. So this distance x actually locates point C at which the incident ray strikes the mirror mm prime. अच्छा, अब अगर लाइट इस रास्ते के थ्रू आ रही है, यहाँ से पहले ए से सी पर और फिर सी से बी पर, तो टाइम कितना दरकार होगा इसको ए से बी तक पहुँचने में? दैट विल बी द टाइम टेकन बाय लाइट along the path ACB. That will be how much? Let us call that time to be t. This will be t1 plus t2. What is t1? T1 is the time in which light comes from A to C, plus t2 will be the time in which light moves from C to B. So the total time will be the sum of these two times. Or this can be written as t equals t1. Now t1 is the time taken for this distance AC. So this will be distance AC divided by the speed of light, which is, suppose this is v here in this medium, plus t2, which is the time for this distance to be traveled. So this t2 will be distance cv divided by the speed of light, and again this is v because light is being reflected in the same medium. You can call for simplicity this distance AC to be d1. So then this equation becomes d1 divided by v, plus you can call cb distance to be d2. So this will be d2 divided by v then. Now according to Fermat's principle, this time should be a minimum. तो ये जो टाइम t है d1 डिवाइडेड बाई c प्लस d2 डिवाइडेड बाई c के बराबर, फर्मास प्रिंसिपल के बराबर इसको मिनिमम होना चाहिए, कम से कम होना चाहिए. और आप इफ़ यू रिकॉल फ्रॉम योर कैलकुलस दैट ए क्वांटिटी विल बी मिनिमम प्रोवाइडेड its derivative with respect to the variable is 0. Then remember, the variable in this case is the x, which represents the location where the light will hit this reflecting surface. Okay, so derivative of time t with respect to x will be equal to 0. This can be written as d divided by dx, and t from the last slide, this is d1 by v plus d2 by v equal to 0. Remember, if light is coming in air, then the speed v will be equal to the speed c of light, and this final equation, this one will then take the form of a derivative d by dx into d1 by c plus d2 by c equal to 0. Or we can factor out 1 over c from here, so this becomes 1 over c into the derivative of d1 plus d2 equal to 0. C, which is the speed of light, which is non-zero, so 1 over c is non-zero, so this means then this derivative term must be equal to 0. So we take this equal to 0. अच्छा, अगर ये 0 के बराबर है, now we want to calculate d1. What is d1? Okay, so look into the figure. Let me draw that figure again over here. This is the reflecting surface where light is coming from some source and approaching some observer in this fashion. So this is the incident ray, this one is the reflected ray, such that this source of light is some distance above this mirror m prime. So this is my mirror m prime, and how much above this source is above this mirror? Let us call that distance to be a. How much is this point b above the mirror? Let us call this vertical distance to be b. Then this distance over here is x, and this total distance between horizontal distance between a and b, this is l. So this total distance is l, this is x, so this means this remaining will be then l minus x. This is the point of incidence, and here we draw a normal. Okay, so if this is normal, then this must be the angle of incidence, which we call theta 1 or I, if you like. And if this is the angle of if this angle is theta 1, then you can say this angle is theta 1. And here now you see a triangle, this triangle, and remember this AC distance is labeled as d1. So d1 in terms of a and x can be written as d1, because this is now a right triangle, and this AC side, which is the hypotenuse of this triangle, this will be equal to the perpendicular side square, a square, plus the base. This distance is x. Okay, so d1 is a square plus x square, square the root. Likewise, you see a second triangle over here, this one. This is my angle of reflection, which you can call theta 2. If this is a theta 2, then this angle will be theta 2 then. And if you want to calculate now this distance d2, which is the hypotenuse, so this will be b square, the perpendicular distance square, plus this base square. This base is, remember, the total length l minus x. So this is b square plus l minus x whole square, square the root. We incorporate the values of d1 over here, which is square root of this quantity, and d2, which is the square root of this quantity. And now take the derivative of these two terms. Okay, so when you differentiate the first term, from here you will get 1 over 2 into the square root of a square plus x square into the derivative of the denominator. So a is constant, the derivative will be 0. The derivative of x square will be 2 times x. And likewise, when you differentiate the second term, this one, you will get again 1 over 2 into the square root of b square plus l minus x square in the denominators, times the derivative of this whole thing, which will be l minus x into minus 1, and this whole thing, according to Fermat's principle, will be equal to 0. Okay, अच्छा यहाँ से ये 2 कट जाएंगी, and what you will get in the is you will get x divided by something like this from the first, minus l minus 6 divided by this thing, and this must equal 0. या इस second term को आप right पर लेके आए, so this becomes positive over here. And now again look into this figure over here. Now you can see this angle is theta I, so this angle is theta I, and in this triangle over here, the sine of this theta I is x divided by a square plus x square, because this perpendicular is a, this base is x. And likewise, this angle is the angle of reflection theta r, so this is the angle of reflection theta r, and we see a second triangle over here, and the sine of this angle theta r will be b square. Now, and this will be the base, which is the perpendicular in this case, opposite to this angle. So this is L minus x divided by the hypotenuse. The hypotenuse is this whole quantity. This means in equation 1, this thing is nothing but the sine of the angle of incidence, and this thing is nothing but the sine of the angle of reflection. So from here we get sine of theta I is equal to sine of theta r. अच्छा, दो एंगल्स के अगर साइंस बराबर हैं तो इसका मतलब कि वो एंगल्स फिर बराबर हैं, तो यहाँ से हमें लॉ ऑफ रिफ्लेक्शन मिलता है। इसका मतलब ये है कि फर्मास प्रिंसिपल जिसके मुताबिक लाइट उस पाथ को फॉलो करेगी एक पॉइंट से दूसरे पॉइंट तक जाने में कि जिस पर सबसे कम टाइम लगे। अच्छा, इस कॉन्सेप्ट से हम लॉ ऑफ रिफ्लेक्शन पर पहुंचते हैं, तो इसका मतलब ये कि फर्मास प्रिंसिपल करेक्ट है फिर। Okay, now we are going to derive the laws of refraction now using the Fermat's principle. And remember, for refraction we need light to be entering from one medium into another medium. So suppose this is some light source where light is coming like this. This is one of the light rays, and this light source is distance small a above the interface. So this is some interface you can call m prime or xy, whatever you like, and these are both transparent medium. So light is coming like this. This is the point of incidence. We draw a normal at this, and what happens, light then enters into the second medium and approaches some point b over here such that it bends. So the speed of light in the first medium is v1, and this is different in this second medium down. Let us call this to be v2 in the second medium. The horizontal distance between point A and point B, this distance is labeled as L, and this distance between point A and the point of incidence is called x then. Okay, so this is the whole story. Light travels from point A which is in the first medium to point B which is in the second medium along the path AOB. So you can see light is coming from here to here. This point is now labeled as O, and then from O to B. So the total path is AOB such that the distance between AO, namely this distance, this is labeled as D1. We call this D1. This distance over here is labeled as D2, and the total distance AB, horizontal distance, remember, this is labeled as L. What will be the time taken by light ray in coming from here to here? Okay, so that will be, let us call that total time in both the medium to be T, and this will be equal to T1, where T1 is the time taken by light in coming from here to here, plus the time taken from here to here, which is labeled as T2. Or T1, you know, this will be this distance AO divided by the speed of light, which is V1 in the first medium, plus T2, this is this distance OB in the second medium divided by the speed of light V2 in the second medium. Or simply this can be written as AO is nothing but distance D1, and OB distance is nothing but D2. So this is D1 by V1 plus D2 by V2. We call this our equation number 1. Now from figure, so the figure is like this. Light is coming this way. This is some interface, and this is the normal, and it bends over here. Okay, this point A is small distance A above the interface, and this final point B over here, this is small distance B below the interface. This angle is angle of incidence over here, theta 1, and this one over here, this is the angle of refraction in the second medium, theta 2. What about this distance? Okay, this distance, horizontal distance between A, this is point A, and this point is O, this is X, and the total distance between A and B, this is B. Okay, so you can see this distance d1 again in terms of a and x can be written as the square root of a square plus x square, and likewise this distance which is v2 d2 in terms of b and L minus x, this distance is L minus x. So d2 is b square plus L minus x whole square the root. Okay, so when you incorporate these values of d1 and d2 in the last equation, which is equation 1, so it takes the form t becomes this quantity divided by v1 plus this quantity divided by v2. We call this equation 2. Remember, this is the total time in which the light rays takes in reaching from the source to the observer in the second medium. And now we are going to apply the Fermat's principle. According to Fermat's principle, this time must be a minimum. तो अगर ये minimum है तो calculus के मुताबिक इसका derivative with respect to the variable, and again variable is the location of the point of incidence x. Okay, so dt divided by dx must equal 0. तो इसका मतलब है कि आप इस इक्वेशन का डेरिवेटिव ले लें और इसको 0 के बराबर ले लें. अच्छा, तो जब आप पहले टर्म का डेरिवेटिव लेंगे तो यहाँ से आपको ये टर्म मिलेगा, और जब आप इस सेकंड को डिफरेंशिएट करेंगे उससे आपको ये टर्म मिलेगा नेगेटिव टर्म साइन के साथ, लेकिन उसको फिर हम राइट पर लेके चलेंगे तो ये पॉजिटिव बनेगा. And again, if you now look into the figure, so this quantity x divided by the square root factor, this is nothing but the sine of the angle of incidence theta 1. Okay, so this becomes, the left hand side becomes sine theta 1 divided by v1, which is here. And this quantity from the figure, if you draw the figure by your own, you will see that this is equal to the sine of the angle of refraction theta 2 divided by v2. And from here again you will write this as sine theta 1 divided by sine theta 2 is equal to v1 divided by v2. And when these speeds are written in terms of the refractive indices of the two media in this patient, so finally you will get in 2 divided by n1, and finally you will reach this format of the equation, which is nothing but the Snell's law. Okay, so this way we proved Snell's law using Fermat's principle.